right, welcome back to Lag Demon Programming and the Compiler Design course. Continuing basically where we left off last time, what we were working on was a visitor called, I've got a lot open here, pretty print, which is just reading our, it's a visitor pattern that's moving through, working through our abstract syntax tree and printing out the code, hopefully in a format very similar to what we, although it's not quite exact, what we put in. I did have to make a few changes, but it's good enough to tell whether or not the abstract syntax tree is correct. And actually I did run into some problems. I noticed some problems in the way it was producing it, and I had to fix some things, and I'll go over those briefly. The changes I did make are up on GitHub, and the link to GitHub will be posted in the description of this video. You can go there and take a look and see the changes on GitHub. But what I changed was, here in the parser, I rearranged the way expressions and R values work. R value down here. An R value needs to actually be an expression, which we had it other way around before. An R value was an expression. Here we need to have an expression be an R value, which will allow any of these things to be an R value, which is those things that we pass into functions or do mathematical operations on, but don't change. Unlike L values, which can also be an R value, and L value is always an identifier. It's a place to store things, and it's a legitimate R value. Then the other thing that I had to do was, it was too difficult to get the parser to parse the way I wanted it to do R value lists, or in other words, argument lists. So I separated them by a comma, and on the function call here, I put that R value list around parentheses. And you can see that here in our test function. Now when you call a function, and we can remove this space if you prefer to look like that, test2, it looks like a standard, more of a standard function call. We pass parameters into it this way. And so when we run this now, and I'll do it, you know what, I'm going to do it from here because it's easier to see, and I can expand this. Let's make sure it's built. It is. So we want to go /game /slant fungeon and testfng, and we'll make this a little bit bigger. And we see now that it printed out our code. And what I'll do is, here, actually, you bring this down to here, spread this out a little, lower this down. I just want to be able to show you kind of side-by-side comparison of the code that we entered versus this. To do that, I'm going to have to take this this here, and I'll pop it over here, and then I'll bring this one back up. There we go. Now we can see it kind of side by side, as long as I don't click on it. So here you can see that the first let statement, compute, it compiled it properly, it reproduced it, very similar to what we have. Same with this one with the nested let statement in it and the expression a plus b. The if then else, one of the differences, when I reproduce it, I write the function call like this. I had difficulty getting that format to compile, which is why we use this comma separated list with the parentheses around the parameter list here. But I reproduce them like this. That tells me that that did pick that up as a function call, test2 with AB parameters. The same here with our Fibonacci. I created a little Fibonacci function here in our new language, and hopefully at some point in time we'll be able to test this and make sure it actually produces, calculates Fibonacci numbers out to n, however far we can take that. It is a recursive function. Unfortunately, doing it this way would not be Fibonacci, probably can't be tail recursive. This call to Fibonacci here is going to go first. And once it calculates it, it's going to calculate this one and so forth to get each one. It's going to work from n downward until n is less than 3, and then it'll return a 1. So we should be able to calculate Fibonacci numbers from that as it passes around. Then down here I created a start function. Now one of the things we have to kind of decide is how are we going to create an entry point. And let's go back to here and look at it on this one. I'll just put this up here. And I will go editor font zoom. We'll do this a few times. Get that a little bit bigger so you can see it. How do we want to designate a start function? There's several ways we could do this. We could say there's a name. We could just call it start or main or whatever. We could have some required arguments to pass in that would be similar to the command line arguments for a regular program. We could do like some languages like Python let you just call a function. We could do something like this, start, right here, and that would tell the compiler when it's executing this to go ahead and execute start, which would run this code, which would call the other code. Or we could do that. In fact, that would probably be the simplest way to do it. But in my opinion, it makes the entry point of a program unclear, especially if we start moving into having multiple files possibly involved. So I want to create a metadata tag, and I think for that I want to do something along these lines here, where we could say something like entry point. And these two things, a square bracket and a brace maybe, or some languages like F# use these things inside here, or we could just use them like this, entry point. That doesn't look too bad. We could also have it able to take parameters, so we could say 1 2 3 4 5 6 string. For the metadata, what we'll do is these will only allowed to be constants. This itself doesn't execute during the running of the program. It's just something that gets stored for the system to be able to use. So these will probably have to be literals. I said constants. I meant literals in here as parameters. So we need to be able to parse this here and then have some knowledge that it should come right before something, a let statement in this case. We could also have metadata that's for the file. We could have different things other than just entry point in here. So I think I want to use, I don't like these because they are part of other syntaxes. They really don't mean braces or brackets to me. I think we'll do something like that. That clearly distinguishes it. So this would be the start of a metadata. This would be the end of a metadata. And we can do two things with that. We can use our lexer to say, okay, we're now only, when we get this first token, we're only processing metadata. So these things would be a special circumstance. They would come out as a special token. So a string token in this case might be like a meta string, so that the compiler part, the parser part, knows that it's parsing metadata when it gets this. When it gets an entry point keyword, it says, okay, this is I'm doing metadata, and I'm going to be expecting meta integers, meta strings, or whatever as parameters. And that can be kept separate from the code, and it can produce a different kind of node, one that gets stored in our context, which is another thing we have to talk about. We have to start bringing our context together. So for the moment, I think what I want to do is capture whatever this is inside these two things here, this entry point and any list of stuff that's in it. But we'll come to that shortly. So right now, the way it stands, it does in fact compile properly, and it understands it. That structure, at least, we've got all of the just about all of the possible structures that it can do in this bit of file here. Although I didn't do, I think I didn't do a character or a string. So let's say let str equal, this is a string, and let chr equal quote a quote. And let's try to compile that, see if it fails. It may. It didn't like something there. Unexpected error. Column 12, line 15. Line 15, column. Is it not coming up with a constant character? Seemed to like string. Okay, let's take this out for the moment. Make sure it does that string. Let string equals, this is a string. Okay, so it captured that. Now why won't it capture our character? Should pick up a character A. It's just saying A there. I'm getting an error now. Very helpful. Unexpected error. We have to fix up our error reporting at some point in time. It's a syntax error on line 15. Well, we'll look into that. I'll come back to that. Let's get going. Let's get going on working on some of these things. So, real quick, I'll go through this print, pretty print one that I fixed up here. The pretty print visitor. It's got a little indent function. I think we did that in a previous video. We can push and pop the indent. So when it comes here, oh, this is a little macro I created, print A. Right now it's just defined as this here. We can switch these and it prints out some debug information. I may take those out. So don't worry about the PRT thing. That was for my debugging process. But it prints out the ident or the visitor. If it's a parameter, it prints out the ident and the type, which we can see. Let test qr compute AB. Is it not printing out the type of those? Did I make do I have another error here that I didn't notice? Yeah, this one, these are compute, that's a parameter. Well, that's a good one to track down. Pretty print parameter. You know what? I'm going to turn the little debugger on here and see what's going on. So all I'm going to do is uncomment this one and comment this one and build it. And what the heck? Why didn't it print? What? Make. Why isn't it printing my debug information? Okay, let's try this. Okay, I don't like something here. Fungeon parser.hpp doesn't exist. Okay, when all else fails, Okay, that worked. Let's try to run this now. That's better. Okay. The build got out of whack for some reason, so let's look at this first one here. I'm going to do this just in case, so I can find the top of it here easily. There we go. We've got our first let statement, compute, identifier. A is an identifier. B is binary expression. We're interested in, let's go back to here. No. Where is it? Where's my test? There it is. Moved around. Seems to. Compute. These should be parameters. Compute. A is coming up an identifier. B. A and B are coming up as identifiers instead of parameters. Okay. I didn't notice that before. Let's look at our parser. Here's our param list as an identifier or a typed identifier. A let statement as a parameter list. Parameter list, typed identifier, or an identifier if it's casting it to a parameter. I think that's what the problem is here. It's going into a parameter list. Here's our AST. Here's our parameter. Here's our parameter list. A parameter is just an identifier with an additional type. So we're getting the identifier and we're casting it to parameter. That's a mistake. What we really need to do when we have a parameter is instead of having this string identifier here is, and it's fine that it can act like an identifier, but what we want to do is have an identifier pointer underscore ident and make this an identifier pointer ident, and then go ident pointer get ident here and the type. So it is an identifier and it's also a decorator for an identifier. And what we want to do here is have a standard string get ident, and we want to return, actually I'm going to say if underscore ident underscore ident does not equal null, we're going to return underscore ident. Oh, actually, nope. What we want to do is have identifier pointer return underscore ident. And then we want to go over to our parser, and where we've got this, we don't want to cast this. We want to say if it's a parameter coming back as an identifier, we want to say new parameter and pass in that identifier. If it's a typed identifier, then we want to go types, colon, colon, I believe I called it, let's go up to types. I believe I called it, no, those are infer. Here. We don't know the type of this parameter, so we need to infer it when we get to that point. And the same thing here, we want to go new parameter, put in the $1, but in this case it's a typed identifier. It came back as a typed identifier. So what we want to pass in is $1 pointer get type. I think that'll work. Let's find out. And now when it, let me do these, appear to the top of this. There. Now we're getting, well, we got 0 float, 0 compute parameter. Oh, yeah. And so now we need to go to our pretty print, because when we print parameter here, get ident, oh, but it's coming back. Is it coming back null? Because it came back 0. I think that's going to cause a segmentation fault. So I got to track that down. It did. Because this node, this parameter node, is returning a null for some reason. It's a parameter. Where is it? Where's parameter? Identifier. There's parameter. Ident. Oh, yeah. Go comma underscore ident. Ident. Didn't initialize it. That's why it was coming back null. And there it is. And come up here, and there we go. A is a float, B is a float. Okay, that's fixed. Okay, Q is an infer, because we didn't type those. Yep, and that's what we're going to use a visitor for. Probably not in this video, but we are going to. So we cleaned it up a little bit. I really wanted to do a little bit more than that kind of cleanup stuff, but you're starting to see some of the subtleties of things you have to worry about in compiler design. So what happened here was a mistake. Let's go back to our parser. And the mistake I made was I was thinking, well, it's a parameter, it's just an identifier, and I was casting it. I was casting the identifier to a parameter, but a parameter really is a more detailed thing. And has got some additional information. So we can use the fact that it's an identifier, but we need to set it up correctly. So now it is set up correctly, and we're really kind of using a combination of inheritance and a visitor pattern to be sure that we've got that identifier stored, and we're also passing it on to the identifier portion of it. And we can still get that identifier object out of it. We could probably do that a little differently, and I'll have to think through it, but we got that part fixed. So Now, if we real quick now go back to our prettyprint.h and up here, let's get rid of this junk so it's not printing out all those debug statements. Build it, run this. Things should look a lot nicer now. There we go. We're getting the types. So here's let compute, A is a float, B is a float, Q is an infer, R is an infer, A is an infer, B is an infer. So it's going to have to figure that out. And that might be problematic here. It'll know it's a number because it's got the add. We'll have to decide about a default there. This is all good. String is just a value, so we'll have to figure that out. N is an infer, and it's picking it up there and it's passing it in. Okay. So now I'm fairly confident that that's working. We still got to figure out why it wouldn't do a character. And I suspect that's actually in our lexer. I'll take a quick look at that before we end this, but character quote, well, that's string buff YY text. That's okay. It allows a quote in there. You know what? I'm going to take a look at something. Oh, no, that won't do any good. Let's see. That's what the problem is. This needed to be char val, and it doesn't need all this. Doesn't need to do any of that. It needs to go YY text sub 0 and return char val and bogus escape in character and new line in character. Let's build it. What didn't it like? Fungeon lval charval. Okay, let's go take a look at the parser real quick. Up here, up. Here we go. Character charval. What doesn't it like? Oh, YY text. Okay, typo. There's our lexer. And it's right here. It's supposed to be YY text. Okay, let's do a make. Good. Let's go to our test FNG. Let's put that let A equal let CHR equal quote A quote. And let's run it. It still doesn't like it. Column 12, line 15. That's it. Column 12. Okay, well, I will look into that and we'll pick it up in the next video. We're right at a half an hour, so I'll end it here. It's probably just the way I'm handling the character constant. We'll fix it in the next video, or I'll show you how I fixed it. So anyway, that's it for this video. Thanks for watching. I hope you liked it. If you liked it, hit that like button. If you really liked it, hit that subscribe button. And if you want to get notifications when I upload videos, hit that notify button. It's the little bell next to the subscribe button. Thanks, and I'll see you in the next video.